next diagram is about a transistorized ignition system. Transistors are everywhere now, so we need to know how they work and how to read them in a diagram. In order to keep this series short, I'm going to make this next video in 3 parts. The first part is how a transistor works. The second part is how the transistor turns on a coil. And the third part is how to read all of that in a diagram. Be sure and watch all 3. Transistors. What exactly is a transistor? Well, according to Wikipedia, it's a semiconductor and it's used to amplify and switch signals and powers. Now, for the purpose of this video, we're going to focus on its purpose as a switch. A switch. Here's 2 examples. The top one is a common toggle switch. It has moving parts. And the bottom one is a transistor. It is a switch, but it has no moving parts. And they can be extremely tiny. This is what they look like. This is how small they can be. And this is where they're located, inside the circuit board. And this is how they're diagrammed. There's 2 types of transistors. One is a negative, positive, negative, and the other one is a positive, negative, positive. You can tell the difference in a diagram by looking at the arrow pointing away or pointing to the base. For this video, we're really not going to look at the difference. They're both switches, so we're going to look at their role as a switch. Here's how transistors are illustrated in a diagram. There's a couple words we need to know: the collector, the base, and the emitter. Here's the typical diagram. In diagnostics, a lot of auto technicians will take the typical diagram and change a couple of these words to make them make a little bit more sense. For example, the collector we call the source, or the source of power, or battery plus. The base we'll call the gate, or the switch, and the emitter is the load, or the motor. Transistors are a lot like faucets. Water comes from the source in a faucet, and it waits at the valve. The flow is controlled by that valve, so you might say the valve is the switch. There's moving parts because you have to open that valve. When the valve opens, water then can flow. Transistors are a lot like faucets, but instead of water, we have voltage that comes from the source, and the voltage waits at the gate like the water waited at the valve. Now, the flow of this voltage is controlled by the gate, but instead of having moving parts, we have moving electrons. And then when the valve opens, or the gate opens in a transistor, current can flow. Once current flows, the load now has what it needs to operate. So thinking of a transistor, think of a water and a valve, and you'll have a pretty good impression of how it works. Now here's some simple logic as we think about this. Whatever comes from the source waits at the gate. So if we have battery voltage, it waits at the gate. Can't make it any farther than that. If the gate is open, the source can then get through it and make it all the way down to the load. And if the load is good, the source will then make it work. And the motor can run. Now if the gate is closed, nothing can get through it. And if there is nothing at the source, there's not going to be anything at the gate. And then of course, if the load is bad, the source can't make it anyway, so the motor won't run. So we do have to have a good load. Now here's a little diagram I got off the internet that kind of helps understand this a little bit as well. You have your collector, your base, and your emitter. Now if there's nothing flowing into the base, nothing can flow from the collector to the emitter. But if you have something flowing into the base, then whatever comes to the collector can go out to the emitter. Again, if something is flowing into the base, then something can flow from the collector to the emitter. Here's another little diagram picture that kind of shows how this works. You would have battery power coming in and waiting into the gate, and once the gate is open, then the current can flow. So that's how transistors work. So now we know how transistors work. They're actually switches with no moving parts. So let's see now how a transistor switches on a coil.